You say that cancer is a big problem for evolution. Why do you say that?
Well, for several reasons, one of which is that mutations are supposed to be the mechanism by which evolution proceeds from microbes to mankind, but we see that mutations actually cause things like cancer. So they're destroying us, they're not creating us. Another aspect of this is that the research into cancer has discovered amazingly complex systems that protect us from cancer, and none of these could ever have evolved by any natural process. So these systems that protect us are just amazingly sophisticated and speak about divine, intelligent creation by a super intelligent creator like the Bible talks about.
But why is there cancer at all then, if God created a very good world from the start?
Yeah, good question.
Cancer is a deeply personal and challenging experience for millions of people around the world. Could it also pose a serious challenge to the theory of evolution? My guest today is Dr. Don Batten, a biologist with a PhD who has a wealth of knowledge in this topic. Don, before we get into the implications of cancer and evolution, tell us simply, what is cancer?
Cancer is basically cells that go rogue. Instead of dividing occasionally, they divide rapidly and repeatedly. And then that forms, for example, in breast cancer, it forms a lump, a tumour. Or if you have leukemia, which is a cancer of the blood, it doesn't form a lump, but it spreads right through your body, through your circulatory system. Or you might have lymphoma, which is in the lymph system. So but basically it's just cells reproducing, dividing out of control.
Right. And why does cancer make people sick?
Well, if you have a lump in your liver, as it grows, it actually affects the function of the liver. The leukemia in your blood affects the ability of your blood to do its job. And so it makes you feel sick, it makes you feel tired, eventually it can kill you.
So how many people get cancer? Is it widespread through all ages or mostly older people? Or what do you think about that?
So cancer rates increase as people get older, but even young children can get cancer, which is very sad. It's interesting that 60% of people never get cancer. 40% of men get cancer, about 38% of women. So slightly less women will get cancer in their lifetime we're talking about, but 60% never get cancer even in their whole lifetime.
Okay, right. And what about creatures? I have heard somewhere that sharks don't get cancer. Is there some research behind that?
No, it's a myth from the 1990s. And so people in the 1990s started consuming shark cartilage. It became available through health stores. And so they were eating shark cartilage thinking that it was going to protect them from cancer. But here's the irony, is that sharks actually get cancer of their cartilage.
Okay, so it's not that helpful.
It's not helpful, and people spend a lot of money on something that's not protecting them from cancer.
Well, what about other creatures? So we've got creatures alive today. Would have cancer been around for dinosaurs?
Yes, interestingly, they've found a theropod dinosaur like T-Rex, which has a brain tumour. So we find cancer in the fossil record, which is interesting because there are people who say, oh, well, the millions of years are correct and therefore God created everything over millions of years. Well, if he did that, then he created animals with cancer before Adam and Eve came along, before sin, before the corruption of the creation. So that's a problem for the idea. If people, say they're Christians, then cancer in dinosaurs doesn't fit with God saying everything was very good when he finished creating everything.
Right. Yeah, that is a bit of an issue when you've got something that causes disease and death.
Yeah.
Right from the start when it's supposed to be very good.
Yeah.
Yeah, well, we might actually look at that later on, but I've got a few more questions about cancer itself. I want to get into the details. So what actually causes cancer? If I'm cancer-free and then later on I get cancer, what's happened to me?
Well, basically, as I said, cells go rogue. So it's caused by The two basic causes of viruses and mutations. So most people would have heard of human papillomavirus, HPV. HPV causes over 90% of cervical cancer. There is a vaccine for that today, but things like hepatitis B and C cause 75% of liver cancer. So these are viruses. So the viruses mess up the cellular action and can interfere with systems that protect the cells, but they basically cause mutations. But mutations are a fundamental cause of cancer, where things go wrong and the cells are reproducing out of control.
Thanks for watching the interview so far. Just a quick one. If you haven't already, make sure you click that subscribe button so you can see more of this content. Back to the interview. Right, so you mentioned some of it's to do with viruses. And I imagine viruses isn't something you can inherit. That's something you catch, I guess. But do you have people actually inheriting cancer?
Yes, so you can inherit a tendency towards cancer, and most people will be aware that in some families, breast cancer runs in families and other forms of cancer. And so if you have close relatives which have the same cancer, then the medical advice could be that you should get checked for mutations that could be causing that. And if you know you have that mutation, you could take steps to minimise the chances of you getting the cancer.
And what are some of those steps that you can take to minimise cancer? That sounds promising.
Yeah, so there are things that can increase your risk of getting cancer, and there are things that you can decrease your risk of getting cancer. So things that increase the risk of getting cancer, some of them are obvious and everybody knows about, like, for example, smoking.
Yeah.
Yeah, so smoking is a really obvious cause of cancer, lung cancer, and smoking actually causes 30% of all cancer deaths. So obviously, if you don't smoke, you're going to reduce your risk of getting cancer. There's other ones like environmental carcinogens, chemicals that cause or predispose you to cancer, things like benzene, arsenic exposure, soot. So one of the reasons why there are strict regulations on diesels is that diesel soot is carcinogenic. Radon in buildings. So the materials that buildings are made out of emit radon, which is a carcinogenic radioactive gas. So today buildings have a lot of air turnover to make sure that this is vented out of the building. So these are some of the environmental things. UV exposure, obviously. In Australia, we're the melanoma capital of the world, so to speak, because of the exposure of people to UV from sunlight.
From sunlight, okay.
So over 90% of melanoma is actually caused by excessive UV exposure.
Right.
And that means those beds that people get into to get a suntan also, they cause melanoma.
Okay, note to self not to go get a tan in one of those.
No, don't go to the tanning thing. So
yeah. Well, there's a lot of things that doesn't sound great. There's a lot of things that could increase our chance of cancer. What about some things that can decrease our chance of cancer? I want to hear about that.
So what you eat. So one of the things that you can eat actually increases the risk of cancer is alcohol. So consistent consumption of alcohol actually increases the risk of esophageal cancer, stomach cancer, bowel cancer, a whole range of cancers. So the flip side of that is don't drink too much.
Yeah.
Minimise your risk. But also positively, if you eat plenty of fruit and vegetables, you avoid processed meats like too much ham and things like that. They're carcinogenic. You eat plenty of whole grains, legumes, nuts. Augment your diet with these things actually will reduce the risk of cancer. And avoid the things like smoked fish is another thing. You know, some countries, they love their smoked fish. That's actually a risk factor for esophageal cancer, throat cancer.
So all these things, these factors you're talking about that can increase the chance or decrease the chance of cancer, I mean, I imagine that when they get into the body somehow, at a certain smaller level, that's where cancer's actually happening. Is it like an organ level, or is it the cells level where cancer's happening? What level is cancer occurring, like right as it's at its start?
So it basically starts in one cell.
Cells, okay.
Yeah, one cell, and that cell goes rogue, and then it reproduces and just goes out of control, goes mad, and that's what causes cancer.
So you're saying rogue cells, they're going out of control. What is the mechanism that actually causes them to not do what they're supposed to?
Well, we actually have three systems which protect us from cancer, and the mutations that cause cancer are known from these systems that actually protect us from cancer. So the mutations are actually errors in the systems that protect us. So there's some amazing research happened because of cancer. There's research into what causes cancer. The first system basically they're called tumor suppressor genes. So they're just like that says, they suppress tumours or suppress cancer. So these genes are actually designed to stop cancer.
Sounds good.
It sounds good. And if they work properly, they do the job well. But mutations in that system can wreck it, and so then we become vulnerable to cancer. So those tumour suppressor genes, I mean, P53 is one that a lot of people might have heard about. Now that system basically is a cell suicide system. So what happens is the cell detects that it's gone rogue and it kills itself. It commits suicide. It's technically called apoptosis, and it's a very sophisticated system of a lot of different components which work together to detect that the cell has gone rogue, and then it actually kills itself. It actually shuts itself down in a very controlled manner. So that's one of the systems which protect us from cancer, and if you get mutations in that system, then make us vulnerable to cancer. Tumor suppressor genes, they're called.
Right. So you mentioned something quite strange, cell suicide. So the cells actually go, all right, I'm a bit sick, I don't want to infect or continue to, I'm gone.
Yeah.
How could evolution explain, that coming about? Is that possible?
Yeah, that's a good question, because how could a system that causes a cell to commit suicide be passed on? How could it evolve to start with? Because it's very sophisticated. But then, if it did evolve, how would it pass it on? Because if it commits suicide, that's the end of the end of it. And how would it be selected unless it was actually forming a useful function? And the useful function is to kill yourself.
It's not very useful, is it?
So how could it evolve to start with? Because there are dozens of components to this system, very sophisticated, and there's you can imagine trying to design a system that actually detects if you've gone rogue and kill yourself. You don't want to actually do that unless you have gone rogue.
Yeah.
Right.
Yeah.
So you've got to have checks and balances to make sure that it's actually working properly.
So if the cell, if it evolves this new feature, before, in a gradual step to getting towards only when it's detecting something rogue, then you're actually, the cell suicide's happening when it shouldn't, before there's any rogue thing there. So you need, it needs to be there, but only there when you've got
Well, it has to be fully functional. The problem is it has to be fully functional. Otherwise, it can't be passed on anyway, because you commit suicide, that's the end of it.
So you mentioned three mechanisms.
Yeah.
We've gone through one,
Yeah.
which is the cell suicide mechanism,
Yeah.
protection. And then we've got, what's number two?
So number two, the name of them is a bit complex. It's called Proto-oncogenes. Proto-oncogenes. So onco is cancer, and genes we know. So they're genes that relate to cancer, and they're proto. Proto means before they become cancer-causing genes.
I think I've heard oncologist. Is that related?
That's a person that studies cancer.
Okay.
Or treats cancer, oncologist. So oncogenes are genes that relate to cancer, and their proto means before they've actually become cancer-causing. So what do? They're like a brake on the rate of cell division. So cells divide, and they say, only divide now, and then go to sleep for so long, and then divide again. So they're actually controlling the rate of cell division. The mutation in the system results in it losing control over the rate of cell division, and cells divide rapidly, completely, and keep on dividing, and then you get a tumour or you get cancer. So
ideally you want to slow that down.
Yeah, so it's like if you think about driving your car, you put your foot in the brake to stop it, and you actually put your foot in the accelerator. And you speed up. So this is basically like taking your foot off the brake and putting it on the accelerator in terms of the control over the cell division.
Right. So when you don't have that protective limiting, so the oncogenes, they're like the brake function.
Yeah.
And when you don't have that, accelerator, and then you get rapid development, rapid division. So there's a mutation called RAS, which is related to lung cancer, for example, a well-known one in this particular category. If you're enjoying this interview so far, you might be interested to know that we also produce the world's most widely read magazine on the creation-evolution debate, Creation Magazine. It's packed with beautifully illustrated articles showing how real science supports the Bible. It's designed for the whole family and is a great tool for strengthening your faith. Sign up now to receive 4 issues per year. Follow the link in the description. So just so I understand that right, in the case of cancer, when you don't have the brake function, the cancer grows much faster.
That's right, yeah.
Okay, so that's a bad thing. What about the third mechanism?
So the third mechanism, another amazingly complex one, and this is a error-correcting system in our cells. So when there's a mutation in the DNA, these error-correcting systems come along and actually fix up the errors. And there's several of these. In fact, there's been some Nobel Prizes for science awarded for discovering these. And it's like I'm the chief editor for Creation Magazine, and we get articles in for Creation Magazine, and those articles have to be checked. And so we have a process of checking these articles for errors. Now, the articles don't come with an error-correcting system. That's intelligence imposed upon the information in the articles by the editors, by me and the other editors, because the whole team of us actually go through these to find errors.
So I write an article, and then I don't do the error correcting. I send it to you.
Well, I hope you do some error correcting, but no.
But a little bit of proofreading.
You submit the article and we do the error correcting. That's right.
Okay, but that's a two-step
thing.
So they think separately. And so you're saying it's more like, it'd be like if I'm writing the article and I've got the error corrector, the editor helping me at the same time.
I don't. As an editor, I don't have to do the error correcting. It's already built into the article.
Wow. Yeah.
So that's what our cells are like. The error correcting system is built into the cells, so that if these errors occur, they're actually fixed before they do damage. So errors in that system, like mutations in that error-correcting system, impair it so it doesn't work properly. And then these mutations get through the system and they stay. So many people would have heard, anybody who's had breast cancer or maybe a prostate cancer would have heard of BRCA2.
Okay.
Or one or two. These are mutations which are related to breast cancer, for example, and prostate cancer. And these are errors in the error-correcting system.
Right. So it means more errors that come along don't get checked.
That's
and
right.
They keep going.
So the spelling errors in the DNA, if you like, don't get fixed. And then that causes cancer.
So you mentioned, like, this is all to do with mutations.
Yeah.
And mutations, like I often hear people who talk about evolution, they'll say mutations and mutations and natural selection. And they might even say random mutations, and to some varying degrees of randomness. But we're seeing mutations causing cancer. So how do you work with these two?
Well, this is a serious problem for the story of evolution, because mutations are the only mechanism they have to explain the origin of new features in creatures, which enables evolution to proceed from, for example, microbes to microbiologists. So, but mutations we know by the damage they do. They cause cancer, they cause disease, and there's over 100 different types of cancer, and mutations are involved in them. So the mutations are wrecking us, they're not creating us.
So these mutations, they're certainly not going to be creating new functions, or like a creature that, let's say it didn't have an eye and then it evolves an eye. Like, you wouldn't expect mutations to lead to that, even with natural selection.
No. So the mutations we see are actually damaging existing things rather than creating new things. Now, somebody might argue that, a damage to an existing thing is new, but they're missing the point. For example, the first system we talked about that protects us from cancer has all these different components that actually, all the proteins and things that have to work together for it to function, and it doesn't work until it's all present. The error-correcting system we talked about, similar. You've got several different very complex nanomotors that are running along the DNA and comparing different parts and then fixing them when there's an error found, and mind-boggling complexity. And mutations cannot create such things. They can just modify what's already there. They can't actually create whole new features like that. That's not just beyond them.
Yeah. I'm just trying to think. I imagine evolutionists would, I don't know, if you want a theory and you've got a theory and you want to prove your theory, you do some experiments and you try and see if it works. Have they done experiments with certain life forms, make them mutate and see if you get more complex life forms?
Yes, indeed. In fact, over 100 years ago, they discovered mutations. And up until at the time, there was a crisis in evolutionary thinking because they realised they needed a way of getting new information into living things, new features like feathers on reptiles where they weren't before, and muscles on things where there weren't before, and etc. And they had no mechanism. Then they discovered mutations, and they were these accidental changes to genes. Well, they didn't know about genes at the time, but they knew that these accidental changes could generate differences. And here they are, new mutations are the mechanism for evolution. So they very excitedly embarked on this program of mutating things. So you'll zap them with gamma rays, for example, would cause mutations, or there's various chemicals that can be used to induce mutations. And so they think, this is wonderful, we have a mechanism for generating new features. And so they got fruit flies, and anybody who's done science in high school would have seen these little tiny fruit flies, ferment flies. And they zapped them with these gamma rays, and they zapped them with gamma rays. I looked at what happened, and what did they get? They ended up with flies with different coloured eyes and stumpy wings, or different wings, or legs where there would have been antennas, and...
So it's not like there's like a superhero movie I think it's The Incredible Hulk, and the storyline is that he gets zapped by a huge amount of radiation.
Becomes Superman,
Yeah, and he becomes super strong.
Yeah.
So they're doing that with the flies.
They're expecting that to happen.
And they think that's going to happen.
They think it's going to happen.
Yeah.
Because mutations are the new kid on the block, and they're going to be the way of getting new features and things, and evolution is going to be explainable through mutations. They never got anything like what they hoped. They just got defective flies.
Yeah. So it's not looking good for mutations.
No, well, so this is one of the reasons today they've gone very quiet on mutations. They don't talk about mutations much. They want to talk about natural selection because the mutations they can't do the job. And cancer underlines that cancer is a consequence of mutations. They destroy us, they don't create us. One example there are beneficial mutations in a certain sense. For example, they irradiated wheat and ended up with dwarf wheat, and that turned out to be good. You might think.
You got smaller wheat, though.
Smaller, shorter wheat, yeah.
So how's that an improvement?
Well, if you're a wheat farmer and you've got the normal high-growing wheat, it's when you get rain and wind, can fall over in the wind, and then it's lying on the ground and it rots, and then the harvester can't pick up the wheat. So with dwarf wheat, though, it's shorter and much less prone to falling over, right, in the wind and the rain, and so it stands up, and then the harvester can come along and harvest it still. So it's a benefit to the farmer.
Okay.
So the beneficial mutation in that sense.
Yeah, but it's not necessarily a new. I guess evolution would be more like. This is an exaggerating, a bit exaggerated, but let's say instead of the wheat, just going shorter, it actually develops a whole new structure of so that it's like structurally engineered in a sense to be resilient at that same height, but it's just reduced its height instead.
That's just reduced its height. That's right. So what's happened is that an error, a mutation in the information in the wheat that says how to make growth hormone results in less growth hormone, so you get short wheat, which is helpful to the farmer. It's not the sort of thing that's going to change wheat into corn or something, or maize.
Yeah. Now, going back to cancer, what aspect of cancer research provides a big problem for evolution?
Well, I think these systems we talked about that protect us from evolution are way beyond the ability of mutations to create. So you think about the cell suicide system, apoptosis, where it shuts down and kills itself if it goes rogue. An incredibly complex system that's just way beyond process of step-by-step mutation, natural selection to create it. It's just not possible. The error-correcting systems, there's no life without them. So they have to be there right from the start. So they can't evolve. They have to be, just happen. Way beyond the ability of mutations, and they have to be there. They can't actually evolve after life because there's no life without them. So these things underline the impossibility of evolution explaining complex life.
Now, I want to talk about something a little bit different. Talk about things to do with the Bible and the biblical history. And we have the story of the Garden of Eden. Now, how do you factor in cancer? Was there no cancer in the Garden of Eden, or was it there but limited? Or how do you explain that?
Well, when God finished creating everything, it said it was all very good. So cancer would not be a part of the original creation. Adam and Eve were created perfect. And in fact, these three systems that protect us from cancer were fully operational in Adam and Eve, and so they would never have got cancer.
Right. So they would have always stopped the mutating cells ever become
If
cancer.
any mutation happened, they would have been shut down. So they would never have got cancer.
But why is there cancer at all then, if God created a very good world from the start?
Yeah, good question. So originally it was very good and there was no cancer. But what happened? Mankind rebelled against God. Adam and Eve rebelled against God. And God warned them that if they did this, he warned Adam, if you did this, then death would come. And he's talking about physical death because when death did come, he said, from dust you came and to dust you return. He's talking about physical death came about because of sin. And so Adam and Eve rebelled against God, and then God withdrew some of his sustaining power, and then things started to fall apart. And so we see death, suffering and disease in today's world, whereas they weren't present originally in the very good creation. God said it was very good. If God says everything's very good, he's not talking about a world of death and suffering and disease. They came about because of sin. So when we look at cancer and other things that afflict us today, we should say, well, how bad is sin that brought that about?
Mm. Will we always be affected by cancer?
No, well, this is an amazing thing, is God's actually done a rescue plan to actually save us from the consequences of our sin. And that's why Jesus came. Jesus is called, in the New Testament, it's called the last Adam, because the last Adam comes to fix up what the first Adam did back in the Garden of Eden. So Adam's the federal head of the human race. So he's like he represents us all. And we in him all fell. And so we live in a world where we have death and suffering and disease. But, Jesus healed people. Why did he heal people? Because he was undoing the effects of this curse of death, in which came about because of sin. And so Jesus healed lepers, he raised people from the dead, and all these things are an indication that he is the one who's come to fix up the mess that came about because of sin. So how did he do that? Well, he paid the price for our sin, taking the penalty for our sin, which is death, as he died on the cross, and then he rose from the dead having conquered death. And so we see he has made a way that we can be released from the effects of sin. And so we look forward in the future when there's going to be new heavens and a new earth. So those who are in Christ, those who are saved from their sin because of what Jesus did, will be part of the new heavens and new earth. And the Bible's very explicit. There'll be no more death and suffering and disease in the new heavens and new earth.
So no more cancer there.
No more cancer, no more sickness, no more disease, no more death. So that's something to really look forward to.
Yeah, I'm really looking forward to that day.
Me too.
It's going to be good. Yeah, well, in the meantime, we do live in this broken world with cancer. Can you summarise for us, Don, cancer and why it proves evolution wrong?
Well, it's a big problem for evolution because what we've discovered about cancer and what prevents cancer could never have come about by an evolutionary process. And also, mutations are supposed to be the mechanism by which evolution proceeds, and yet we find that mutations are a mechanism that actually destroys us. And so we are running downhill. Instead of going uphill, becoming Superman, we are actually decaying, we are actually degenerating. And so given time, currently about 60% of people never get cancer in their lifetime, but if we keep on going the way we are, the number of people who can get cancer will increase because we are degenerating, we're not actually improving. So evolution is not happening, we are degenerating. Mutations are destroying us, they're not creating us, they cannot be the mechanism for evolution.
Well, thanks, Don, for sharing all this information about cancer and how that it actually proves evolution wrong. Now, we've actually got a documentary called Evolution's Achilles Heels, and we're offering it as a free stream. And this documentary's got not just information about genetics and why evolution's wrong from the biology side of things, but other topics like astronomy, geology, all these other fields where people try to appeal to evolution being true, and the evidence actually shows the opposite.
That's right.
So can you tell us a bit more about this documentary?
Yeah, so here's a DVD version of the documentary, but it's also by streaming from the website. So it's available, and it'll be available for free. We have 15 PhD scientists involved in the production of this, a number of them from Creation Ministries International. Also lots of really interesting animations. So as you say, it covers a broad spectrum of claims that supposedly support evolution, but when you actually start digging into them, you find that they actually don't support evolution. That's why they're called Achilles heels. So when you look at the Achilles heels, you find they don't support evolution at all, like mutations. And mutations don't, we've been talking about those in reference to cancer. We deal with mutations on there, natural selection and things like that. It's supposed to be evolution. They don't work to actually explain evolution at all.
I think that's amazing that even these areas of science which evolutionists point to try and prove their theory, when you look at the detail, that actually shows that evolution isn't true. If you want to watch this documentary, have a look at the video description below. There's a link down there. Click on that and it's completely free and you can watch the documentary later. Thanks, Don, for sharing all this wonderful information with us today. I certainly feel much more equipped with this knowledge to explain to people why evolution isn't true.
Thanks, Michael. It's been a good conversation.